Hey everybody, we're going to do some arithmetic sequences and series, chapter 8. Very exciting stuff here, so let's get going. As always, as I progress through these first couple slides, I'm going to talk a little bit about them, but then if you need to, pause the recording so that you can copy it all down. All right, so first, an arithmetic sequence is a sequence of numbers where successive terms have a common difference. So if you look at the sequence that is there, it's 1, 3, 5, 7, 9. Obviously, it's just odd numbers, but from one term to the next, you're adding or subtracting. That's basically what's happening with an arithmetic sequence. It's arithmetic, so it's just addition or subtraction. So in this particular situation, we're adding 2 to every term to get to the next term. Symbolically, below there you have a sub 1, a sub 2, a sub 3, a sub 4, and a sub n. Those just indicate the positions of your terms. So in the one that we wrote, the 1, 3, 5, 7, and 9, a sub 1 is 1, that's the first term, a sub 2 is 3, that's the second term, and so on. So the subscripts represent the position of that term in the sequence. All right, a couple formulas we got going on. So the nth term of an arithmetic sequence, you've seen this before. We did it in Algebra 1, you did it again in Algebra 2. So there you go. It's a sub n equals a sub 1 plus n minus 1 times d. When I do these problems, will put the d in front of the n minus 1 just because that's what we're typically used to seeing when we have our distributive properties. So that's where I like to have it. So that's where I put it. All right, then we have an arithmetic series. So a series is, the difference between a sequence and a series is just that we're going to add the terms together. So for a series, it's actually going to end somewhere and we're going to add them together. So we're going to use this formula S sub n. So that's the sum of the first n terms is going to equal that n over 2 times a sub 1 plus a sub n. So first term plus last term. And that's really all that means. So you need to know those formulas. All right, so let's get going on our examples. Example 1, a sub 1 equals 15, a sub 2 is 21, and 820 is what we're trying to find. So our formula for this guy is a sub n equals a sub 1 plus d times n minus 1. Now d represents the number that is added or subtracted from one term to the next. All right. So that's the formula that we're going to use for everything. So in this case, we don't know what d is, but off to the side here, and this is just what I do kind of mentally, I take my second term minus my first term, and that gives me d. All right, so this is your thought cloud. This is what you're going to do in your head. Whether you need to show it or not, you know, it's kind of up to you. Like 21 to 15 or 15 to 21, you can kind of do in your head. But in some of the situations where they're fractions or negative numbers, we don't necessarily have the abilities to do those in our head. So that's your process. You take your second term minus your first one, and that'll give you your d for an arithmetic sequence. All right, so the rest is just substituting into my formula and going. So my a sub 20, my 20th term, will equal 15, my first term, plus 6 is my d, and then my 20 minus 1. So n is 20, and then minus n. So I'm getting that from my subscript because I'm looking for the position of 20, and that's what n is. So now I'm just going to go through and figure it all out. So 6 times 19 is 114, so we're going to have 15 plus 114, and that's going to equal 129. So my 20th term, without having to write out all 20 of them, is 129. All right, in B, same idea here. We're asked to find a sub 100, which is a heck of a lot harder, you know, if you actually want to list all of your numbers and you actually want to add 6 to each thing in A and then go to the 20th term. Some people like to do that. I find that completely annoying, and that's why these formulas exist. So in this case, I don't have to find d. They're telling me how I get from one term to the next, so I don't need to find that value, but I do need to find a sub 100. Same formula. A sub 1 is 7, d is 3, and then now my n minus 1, my n is 100, so n minus 1 is going to be 99. And then I just figure out those values. 7 plus 297, which gives me 304 for my 100th term. Okay, so you can see obviously that the formula is way helpful there. I mean, you're not going to really write out 100 terms for that sequence. That would just be annoying. All right, so here we go. Example 2, find the next 4 terms of the arithmetic sequence. Nice and easy here. Again, you have to kind of think about this to find your D, but hopefully that's not that big of a deal. To find D, we're going to take the second term minus the first one, so -2 minus -5. So you get a D of 3 there. Oops, not D, it's 3. Sorry about that. So D is 3. So now I'm just going to add 3 to each term, and then that gives me the next 4, and I just list 4 of them. So 1 plus 3 is 4, add 3 again, add 3 again, and add 3 again. And you get your sequence, or your next 4 terms of the sequence. Part B is just like example 1, where I'm finding the 47th term. It's just given to me in a different format here. So they actually give me the sequence. I have to figure out my D. I have to locate all my stuff. But it's the same formula that we're going to use. So A sub 47 is going to equal my first term, which is -4, plus now my D. So again, over here with my thought cloud, I'm going to take my second term minus my first term, and that gives me 3 as my D. So then I'm going to put that in there. And then 47 minus 1 is 46. So now it's all just calculation from there of the right-hand side. So we have -4 plus 138. Add those together and you get 134. So your 47th term in that sequence is 134. So again, you know, that's just kind of like way easier than writing those things out, but it's up to you. All right, then part C here, they give us the 19th term, they give us a D, and they want us to find, it's a mystery, the first term in the sequence. So same exact formula that we're going to use, so hopefully by now you kind of know this formula. Our A sub 19 is 42, so 42 goes in our first spot on the left-hand side. That's new. And then we want to find A sub 1. So that's also new. We haven't really solved for A sub 1 yet. My D is -2/3, so I'm going to put -2/3 there. And then I have my parentheses. And my 19 is my N. My N is 19. So 19 minus 1 is 18, and that goes in my parentheses. So now it's just a matter of solving for your variable. So I'm going to multiply -2/3 times 18. So I get 42 equals A minus 12, and I add 12 to both sides. So A sub 1 equals 54. Sorry, there should be an A sub 1 there. But remember, that's what I'm trying to find, my first term in the sequence. So really in this one, I would be going backwards. I have the 19th term, and I want to kind of figure it out backwards if I keep doing the -2/3. Where would that take me? So my first term of that sequence would be 54. All right, moving along. Example 3. How many terms in the arithmetic sequence 18, 24, ... 336? So basically what's happening here is your first term is 18, your last term is 336, and you want to find n. So this formula that we've been using on every single problem is really just that. It's just a formula, and we're solving for different things each time. So it's just a matter of what it is that you need to find. So in this case, the 336 is our last term. We just don't know what position it holds. 18 is our first term. Our D, hopefully, again, you can kind of do that in your head, but your D is 24 minus 18, which is 6. So that's our thought cloud over there to get D. And then we're going to put that in there. And then we have our N minus 1. So that's our formula with everything that we know filled in. And that's what you're going to do each time. Take your formulas, fill them in as much as you can, and then solve for whatever it is that you don't know. So now we're just going to solve this thing. We're going to subtract the 18 from both sides. So that gives me 318 equals, and I'm going to distribute the 6 as well. So I'm going to have 6n minus 6. Add the 6 to both sides, and that gives me 324 equals 6n. And then I'm going to divide both sides by 6, so n is 54. So what that actually means is starting with 18, that's my first term, 336 is my 54th term in that sequence. And that's what I tried to find there. All right, so I'm going to end part 1 here, and then we'll pick it up again in a minute.